Hi, welcome to the screencast for the 16.3.16.4 partner quiz over the environmental option. So number one asks, state the part of the electromagnetic spectrum from which Earth absorbs the most radiation. A lot of people went with UV, but actually it's visible light that we mostly absorb. If it was predominantly UV, we'd have a lot of troubles with crops being burnt as well as a lot of skin cancer, just that much even UVA and UVB. So visible light is the predominant one. And then the part of the electromagnetic spectrum from which most of the radiation that Earth re-radiates, that's infrared, because the visible light, when it slows down, the next longest wavelength below red is infrared. So it's slower visible light is going to become infrared. Part C says explain on a molecular level how greenhouse gases absorb the radiation, and what IB wants you to realize is that it's the covalent bond in the greenhouse gases, and it vibrates at the same frequency as infrared radiation does. So that means these greenhouse gases have covalent bonds that can easily absorb infrared energy or radiation, especially a carbon-hydrogen bond or the carbon-oxygen double bond. So CO2 and H2O, OH bond as well, CH4, are all good greenhouse gases. Give and explain one reason why the greenhouse effect may be increasing. There's just a lot more CO2 in the air, and you could give the reason being for more car engines. There's also more CO2 in the air from cutting down a lot of forests, so CO2 isn't being removed at the levels it used to be. But any man-made reason for increasing the CO2 level would be appropriate here. And then part E says carbon dioxide is the most significant greenhouse gas and methane is the more important greenhouse gas than carbon dioxide. Explain how both these statements can be considered correct. CO2 is more prevalent. Cars, transportation by far puts the most greenhouse gas into our atmosphere. But CH4 has 4 bonds, so molecule for molecule, methane will absorb more of that infrared energy. Number 2 then says, state one man-made source of particulates and outline the effect of particulates on the Earth's surface temperature. Incomplete combustion of fossil fuels, whether it's in your car or burning coal for power plants, but the incomplete combustion is going to put the soot up there, the carbon. And this isn't greenhouse gas. Particulates are actually going to keep sunlight from reaching us, and that's something called global dimming, and that will lead to a decreased temperature. Number 3 says use equations to show how ozone undergoes natural depletion in the atmosphere. If you look in your book, there's several equations. I included the two that take you from O3 to O2 the most easily, and that's O3, and I should have indicated here that it involves UV light as the catalyst. So I'll put a little, let me get my marker here. I should have a little UV there. If you can tell that says UV. And that splits it into O2 and an O free radical. And then another O3 molecule can combine with an O free radical and form 2O2. One pollutant that contributes to the lowering of the ozone concentration in the upper atmosphere, the key here is that it's in the upper atmosphere, so the pollutant has to reach the upper atmosphere. So CFCs and nitrogen oxides are the main cause of it. And again, because it's in the upper atmosphere, aerosols, refrigerants, freons, those things all get the CFCs into the upper atmosphere. So these first 3 are all contributors of the CFCs, or they were before they were outlawed. And then the jet engines would be the appropriate source for nitrogen oxide. Car vehicles really aren't considered a source to the upper atmosphere because NO2 undergoes underchanges. It typically becomes acid rain rather than getting up into the stratosphere. So that's the distinction on that. And then fluorocarbons and hydrocarbons are now considered as alternatives to some ozone-depleting pollutants. Outline one advantage and one disadvantage of the alternatives. The big advantage that any alternative to CFCs needs is that it needs to have lower reactivity with the ozone, is what they mean. Lower flammability, because you don't want highly flammable aerosols, that's just dangerous. And lower toxicity. You don't want something that's going to be poisonous as well. But the big disadvantage to all of them is even though we've improved those other 3 things, They're all greenhouse gases, so any kind of aerosol is going to continue to increase the amount of greenhouse gas in our atmosphere. And that is it for the second quiz.